Let's now talk about the useEffect hook in React. Now, as we're building our custom functional components, there will be times when we want them to do some extra stuff at certain times. That's where useEffect comes to the rescue. The useEffect hook is like having a personal assistant for our component. It's there to help us perform tasks at specific moments during our component's lifecycle. It's like saying, hey, when this component shows up on the screen, do this thing, or when something changes, do that thing. We can think of useEffect as a handy function that runs after the component has finished rendering. It's like a little sidekick that watches over our component and jumps into action when needed. What can we do with useEffect? Well, pretty much anything. Need to fetch data from an API? You got it. Want to update the title of your web page? No problem. Need to clean up resources or subscriptions? useEffect has your back. The cool thing is useEffect is super flexible, and a lot of this we will see it apply in practice through examples to make it more clear. So let's go ahead and do that. In VS Code, we're going to navigate to the counter component. This is a component that we had created previously in our course. Now, if you're not familiar with it because you might be watching the course out of sequence, let's do a walkthrough. This is a component that does this very simple thing, which is it maintains a counter and it allows the user to increment that counter. And if we look at the code, the counter is a state variable that is initialized with the useState hook. In rendering the component, we display a message which says the current counter value is X, and we have a button. The button allows the user to increment the counter by 1. Now, if we head to the browser, we will see this custom component rendered. Very simple. And so what we want to do in looking at the useEffect hook is first to look at the life cycle of components in React. So let's go ahead and first let's print a message on the console which will tell us when the counter component is rendered in the browser. So we will create a console.log and we will say counter component is rendered. So that will allow us to see when this component is rendered. So we will do a refresh, we will open the developer console, and we will see a message that says the counter component is rendered. So nothing special. Now if I increment the counter by 1, we will see the component is re-rendered. And that is because, as we previously discussed, whenever we change the state in a component, it causes that component to re-render. And hence, for that reason, we are seeing this message that the counter component is rendered. Now suppose, as an example, what we wanted to do was we wanted to show a message to the user anytime this custom component was first added to the DOM tree in our web application. So how can we do that? Well, in the CRUD form, what if we just add an alert message here? Hi user. So let's say what happens. What we will see is the alert is triggered because the component was re-rendered. But if I increment it by 1 again, well, the alert came up again. This is not the behavior I want. I just want the alert to be shown to the user the first time this custom component is added or shown in the web application. So what can we do? And that's where the useEffect hook comes in. The useEffect hook is able to essentially perform side effects by executing a certain code when certain conditions are met. Now let's take a look. The first thing that we will do is we will import the useEffect hook from the React library. So let's do that. useEffect, and we will import it from React. Now what we want to do is we want to use the useEffect. So to use it, we invoke it as a function, similar to how we were using the useState hook by invoking it as a function. Now, similar to useState that accepts the initialization value, useEffect accepts the function or the arrow function that should execute when the conditions of the useEffect hook are satisfied. So let's create an arrow function, and in the arrow function we want to move the code that alerts the user. So let's move that, and we only want the alert to be shown to the user when the counter component is added to the DOM tree. Now to do that, useEffect actually has a second parameter, and the second parameter is a dependency array. In the dependency array, we can provide variables or other data elements that we want to watch for, and when those change, the useEffect hook will be executed. But if we were to leave the dependency array as blank as what we have done now, what this will tell the useEffect hook is execute this code when this component is added to the DOM tree, and do that only once. So now if we were to save the code, go back to the browser, we will clear the console, we will refresh the browser, and we will see the alert is shown to the user because the counter component is getting added to the DOM tree. So let's click OK. Now if I were to increment the counter by 1, we will see the counter component is getting re-rendered, but our alerts are not showing up. And that is in essence how we can use the useEffect hook. For example, if we wanted to execute some code to maybe fetch data from the server, and we only want to do that once when the custom component is loaded, that's how we can use the useEffect hook. Now there are a few more scenarios of useEffect. Let's explore those. Now let's take it a step further by adding data elements to the dependency array of the useEffect hook. Now in our counter component, what we will do is we will actually create two counters. So we will rename the first counter to counter 1, and we will create a second counter which is counter 2. And in the JSX, we will add a React fragment, and we will create a similar layout for the second counter. And here we will say the counter 1 value is, and we will evaluate to counter 1 state variable, and we will say the counter 2 value is, and we will evaluate counter 2 state variable. Now what we want to do is we want to as well update the event handling functions. So handle click 1, and this will take care of update counter 1. The console, we will update the console message as well. Now we will do an update, and we will change the 1 to 2, and we will do the updates everywhere in this event handling function. So once that is done, what we want to demonstrate is how can we watch for updates in useEffect for variables. So that's what the intent of creating two counters is. So now that we have done the code updates, now suppose we were to save this and go to the browser. We will get rid of the console errors and we will refresh the browser. We will see that the two counters are now getting rendered. Now these are independent of each other because we're using two state variables. Now suppose we wanted to show the user a particular message only when the counter 2 is updated. We don't want to show the user anything when counter 1 is updated. So what can we do? Well, that's the second scenario where useEffect comes in handy. If in the useEffect hook we were to add counter 2 in the dependency array, what will happen is if we now look at the browser, refresh, and if I were to update counter 1, the alert is not triggered. But if I were to update counter 2, the alert is triggered. So that is in essence another way useEffect allows us to watch for updates to state variables that might want to trigger a certain piece of code to be executed. For example, in a React application, we might have a component that displays tabs, and we want to trigger a different API call to the server depending on which tab the user selects. In that case, we would use the useEffect hook. And in the useEffect dependency array, we will provide the state variable managing the currently displayed tab index to determine which code should be executed. And that is the second scenario or use case of the useEffect hook. Now let's go on to the next use case of the useEffect hook. For this use case, we will create another custom component to demonstrate the functionality. So let's go to the components folder. We'll create a new file and we'll provide a name of this new component, resizable component.tsx. Now to save us some time, I've already written some of the code. And what is happening right now is we have a state variable called window width that is using the useState hook. The state is initialized with the browser's window's inner width property. And in rendering in the UI, we're simply displaying a number, which is the state value of the window width variable. Now let's go ahead and add this custom component to our app component. So we will get rid of the counter component we will add the resizable component from our source code. And now we will save and we will open the browser. And what you will see is it shows the current width of the browser as captured by the window.innerWidth property. Now, if I were to do a resize of the browser, what will you notice? Well, the property isn't changing. Why is that? Well, what we haven't done is we have not defined the update in terms of how our state variable should be updated every time the window is resized. To do that, let's first add an event listener. And adding event listeners is very common when we're developing applications. In this example, it's a very simple example, but it will demonstrate the purpose that we're trying to illustrate. So let's create a useEffect hook. In the useEffect hook, we'll have an arrow function. And this arrow function will add an event listener. So window.add event listener, and the event listener is going to watch for resize, and it will execute a function, and we will call this function handle resize. Now we need to define this function, so let's go ahead and define that. So const handle resize equals an arrow function, and in the arrow function what we will do is we will update our state variable by calling the updater function. So update window width by taking the current window width just as a good practice, and we will now set the updated window width, which is going to be window.inner width. So that is the update event handling function for the event listener. Now let's go back to the browser and see what happens. The value is still rendered. Now if I were to resize the browser, what will happen? Well, the values are updated. So it works as expected. But we've actually made one error in how we are dealing with event listeners, which is that when the component is rendered for the first time, we have not defined when we want to add the event listener. And in this case, we only want to add the event listener every time the component is mounted. We don't want to add the event listener every time the component is getting rendered. If we do not provide the dependency array, then the useEffect hook will render every time the component is rendered. That's not what we want. Now, by adding the empty dependency array, this will only execute the event listener to add that when the component is added to the DOM tree. So let's go ahead and see how the application behaves now. It still works. But if you're aware of how JavaScript works, or you are an experienced developer, you know we're still doing an error in our logic. And the error is we have added an event listener, but we never removed an event listener. So what that means is as we continue to add more complexity to our application, what will happen is we'll keep adding event listeners, but we won't do any cleanup after them. So if for some reason our custom component is unmounted or removed from the DOM tree, depending on how our application behaves, the event listener will continue to be listening for the event. But we don't want that. We want to remove the event listener when the component is unmounted or removed from the DOM tree. So for that, what we need to do is in the useEffect arrow function, we need to essentially return another arrow function. This function will be executed by useEffect as cleanup. So let's do that. So window.remove event listener, and we will have the resize event, and we will remove our function. So the important thing to note is when the return function is executed. Now to illustrate that, let's actually add some console log statements. So console.log, and we will write here useEffect executed to add listener. And similarly in the removal, we will do useEffect return function executed to remove the listener. Okay, so now let's go to the web application and see how this behaves. I will open the console so we can watch for the console messages. Now what we will see is, let's refresh the components so we are not looking at stale messages. What we will see is The first time the component is rendered, useEffect is executed to add the listener. Now, if I were to resize the window, the listener is not getting re-added every time the window is getting resized. But what would happen in the case of removal? Now, in this example, it's a little bit hard to demonstrate. So let's go ahead and look at another example. What we will do to essentially unmount our resizable component from the DOM tree is we will wrap this in another component that is able to toggle it as on and off from the UI. So let's go ahead and create another component in our project. In the component folder, we will call this component container. Now, I've already written the code for this parent container component. Let's take a look. What this does is essentially it imports the useState hook from the React library. It imports the resizable component from our project code. It has a state variable, which is display. And initially it is set to true because initially we want to display the children that we will have in this container component. In this container component as well, in the JSX, we have a button. The button allows the user to toggle the display. And we have an event handling function for the on-click prop of the button that essentially just triggers the display state variable to be the opposite of what it currently is. So if it's true, it becomes false. If it's false, it becomes true. And as well in JSX, we're using the expression short form to render the resizable component depending on the value of the display state variable. If it is true, the resizable component will be in the DOM tree. If it isn't, then the resizable component will not be in the DOM tree. Now what we will do is we will navigate to the app component, and rather than using the resizable component, we will use the container component. So let's go ahead and do that. We will remove the reference to the resizable component. Now let's go back to the browser, and you will see that we have the parent component displayed, which has the toggle button, and we have the resizable component displays, which is the children of the container component. Now, if I were to open the developer console and look at what we have, let's clear the console and refresh the browser so we're not looking at old messages. So what you will see is useEffect executed to add the listener, and that is the resize listener that we had added in the resizable component. Now, if I click on the toggle display, what you will notice is the resizable component is removed from the DOM tree. And because we provided the return value or the return function in the useEffect of the resizable component, let's take a look, which was right here. What has happened is in the browser, the event listener has been removed. And this is in essence how useEffect allows us to execute a return function as a cleanup code. So in essence, when we're using useEffect to maybe add listeners in our browser, we should have return functions that remove those listeners. And similarly, we might have other scenarios that would leverage or would need this functionality, and that's what we should do. So that is in a nutshell the useEffect listener in React.